Hello, data enthusiasts, and welcome to Big Data Foundations Discovering the Principles of Apache Spark. This is the podcast where we dive deep into the world of big data processing and uncover the secrets behind the powerful and versatile Apache Spark engine. In each episode, we'll explore the core principles that make Spark a game changer in the world of distributed data processing, while also discussing its numerous applications, libraries, and best practices. So whether you're a seasoned data professional or just starting your big data journey, you're in the right place. Join me as we navigate through the fascinating landscape of Apache Spark and unlock its full potential to revolutionize the way we handle big data. Before we dive into the exciting world of big data and Apache Spark, let me take a moment to introduce myself. My name is Estera Kott, hailing from Poland, but now happily settled in Redmond, Washington State, here in the US. I'm deeply passionate about creating ethical innovations centered around cloud computing, data, and AI. With a strong foundation in engineering and computer science, I've spent the past 10 years in various roles across R&D and management. Previously, I was a senior cloud solution architect at Microsoft, where I focused on machine learning, deep learning, big data, and MLOps. Today, I'm a product manager at Microsoft working with the talented Synapse Spark product group. Together, we're developing products that are truly revolutionizing the way we handle data. So now that you know a bit about me, let's embark on this incredible journey together and explore the fascinating realm of big data processing and Apache Spark. You know, Apache Spark has been with us for quite some time now, but it still amazes me how often I come across folks, especially the younger generation, who aren't fully aware of its rich history and the various components that make up its ecosystem. So in this episode, I'm going to take a fun and engaging trip down memory lane to learn all about the origins of Apache Spark and the incredible array of components that have come together to shape its ever-evolving landscape. All right, friends, let's kick off this journey by talking about big data and distributed computing at Google. When we think about scale, it's impossible not to think about Google's search engine, right? It can index and search the vast expanse of data on the internet at breakneck speeds. The name Google has become synonymous with scale, and fun fact, it's actually a play on the mathematical term Google, which is a 1 followed by 100 zeros. Now, traditional storage systems like relational database management systems and conventional programming methods just couldn't keep up with the massive scale that Google needed to build and search through the internet's index documents. This need for innovation led to the creation of the Google File System, abbreviation is GFS, MapReduce, MR, and Bigtable. So GFS came in as this fault-tolerant and distributed file system, working across loads of commodity hardware servers in a cluster farm. On the other hand, Bigtable provided scalable storage for structured data across GFS. Then, MapReduce brought a fresh parallel programming paradigm to the table based on functional programming, perfect for large-scale processing of data distributed over GFS and Bigtable. In a nutshell, your MR MapReduce applications work hand in hand with the MapReduce system, which sends computation code like map and reduce functions to the data itself. This approach prioritizes data locality and cluster rack affinity over bringing data to your application. Now, let's talk about how cluster workers come together to aggregate and reduce intermediate computations, ultimately producing a final output that's stored in distributed storage and accessible to your application. This approach significantly reduces network traffic and keeps most I/O local to the disk rather than sending it all over the network. You see, a lot of the work Google did was proprietary, but their ideas led to innovative developments in the open source community, particularly at Yahoo. They were also grappling with big data challenges for their search engine. Google's GFS paper provided a blueprint for the Hadoop file system, HDFS, and MapReduce, which became part of the Apache Hadoop framework. Hadoop gained widespread adoption, but MapReduce on HDFS had some shortcomings, like being difficult to manage, having a verbose API and taking a long time to process large batches of data jobs. Even though Hadoop MapReduce was great for general batch processing, it wasn't quite up to par for combining other workloads like machine learning or interactive SQL like queries. Engineers then developed bespoke systems like Apache Hive, Apache Storm, and Apache Impala, each with their own APIs and cluster configurations, which added more complexity to Hadoop and made it harder for developers to learn. This led to the question, could Hadoop and MapReduce be made simpler and faster? Researchers at UC Berkeley took on this challenge and created Spark. Their goal was to make Spark simpler, faster, and easier to use. Early papers on Spark showed that it was 10 to 20 times faster than Hadoop MapReduce for certain jobs, and it only got faster over time. By 2013, Spark had gained widespread use, and its creators donated the project to the ASF and formed a company called Databricks. They worked with the open source community to release Apache Spark 1.0 in May 2014, setting the stage for frequent future releases and contributions from various commercial vendors. So folks, let me tell you, Apache Spark today is a real game changer in the world of big data processing. We're currently on version 3, 3.2, and 3.4 is about to be released. So that's a little bit of the history behind Spark and how it came to be the powerhouse it is today. And we've come to the end of this episode of Big Data Foundations, discovering the principles of Apache Spark. I hope you enjoyed this discussion and learned something new about the history and evolution of Apache Spark. Remember to stay tuned for our next episode. If you enjoyed the podcast, don't forget to subscribe, share it with your friends, and leave me a comment. I'd love to hear your thoughts, so feel free to connect with me on social media. Until next time, happy data processing, and see you in the next episode.